Part 2 wants us to find the value of the gradient when the curve crosses the x-axis. The curve crosses the x-axis when y equals 0. So we need to work out the x-coordinate that makes this equal to 0. And if we've got a fraction, which we have here, that equals 0, then it's the top, the numerator, that needs to be 0. So that leads us to be able to say 4 ln x take away 3 needs to equal 0. If I add 3 on and divide by 4, I get that ln x needs to be 3/4. And if ln x is 3/4, if you remember that if y equals e to the x, then x equals ln y, then to get the x, we can do what we've got here. We can do e to the power of 3/4, and that will give me this value here. So x is equal to e to the power of 3/4. I'm not actually going to work out that value because we're then going to put it in here, and it asks for the exact value. So there's no point in working out what this is, because that won't give us an answer in exact form. So we're now going to take this x and substitute it into the gradient function to find the value of the gradient. So when x equals e to the 3/4, dy by dx is going to equal 24 divided by e to the 3/4 times by 4 ln e to the 3/4 plus 3, all squared. So let's deal with the bracket first. Ln of e to the 3/4 is going to be 3/4. That's going to undo itself. The ln and the e are inverse functions, so that's just going to come out at 3/4. 3/4 times 4 is obviously 3, and then if we add on 3, we'll get 6. So we've got 24 over 36 e to the 3/4. 24 over 36 is 2/3. So you can either write this as 2 over 3 e to the 3/4, or you could also bring this e to the 3/4 up and write it as 2 e to the minus 3 over 4 all over 3.